Oh, hi there. Didn't see you there. I was just thinking of some math that I was doing the other day, and something on my mind that was catching me off guard was the Simpsons rule. Have you heard of it before? No? Oh, well, it's a really fascinating subject in calculus. Let's go check it out. First, the Simpsons rule is a technique in finding the integral of f of x on the limits a to b. The formula is delta x over 3 bracket f of x0 plus 4 f of x1 plus 2 f of x2 plus 4 f of x3, continuing the pattern all the way to f xn bracket. Delta x is equal to b minus a over n. Please taking note that b and a are the limits of the integral. Also, please take note that n is equal to each subinterval of equal. Right here we have an example that we will apply that we can apply the Simpsons technique to. So, little review: the Simpsons technique is used to find the approximate of the definite integral. So, right here on limits from 0 to 3, we have 1 over 1 plus x to the 5th dx. The 1 over 1 plus x to the 5th is going to be our f of x, with our n equaling 6. With Simpsons rule, it's a key note that the n has to be an even number. So, right here on our scale from 0 to 3, we're going to have 6 subdivisions. So there's 1, 2, 3, 4, 5, 6. So at 1 half, 1, 3 halves, 2, 5 halves, and then eventually 3. Okay, so then we also have to get right here that delta x, sorry, my marker a little dried out. Delta x is equal to 3 minus 0 over 6, which is going to equal 1 half. And if you remember from looking at the formulas earlier, that we're going to have delta x over 3, which is going to equal 1 half over 3, which is going to be 1/6. So right here we have 1/6. Then we're going to have f of x0 plus f x1 for f x1 plus 2 f x2 plus 4 f x3 plus 2 f x4 plus 4 f x5 plus f x6. So as you can see at this point right here, that you can tell that it's going to be a little bit of tedious work. So if you start plugging in things, you're going to get 1 over 6, and then it's going to go. You're going to start plugging in for f of x. So right here with 1 over 6, we're going to have 1 over 1 plus 0 to the 5th plus 4 1 over 1 plus 1 half to the 5th plus 2 1 over 1 plus 1 to the 5th plus 4 of 1 over 1 plus 3 over 2 to the 5th plus 2 1 over 1 plus 2 to the 5th plus 4 1 over 1 plus 5 over 2 to the 5th plus 1 over 1 plus 3 to the 5th. So as you can tell at this point, that is going to be very tedious work when finding the approximate definition of 0 to 3 at 1 over 1 plus x to the 5th. So to clear up a little space right here that you may be able to see a little more of the work. So I know in calculus, I don't think I really need to show the algebra section of this because if you're doing this kind of level math, I'm sure you can do a little basic algebra. But your final answer is going to be approximated at 1.07491 5. When you add all of these up and then you multiply it by 1/6, this is going to be your final answer. So when doing the Simpsons rule, just take note that n must be even and that when using the Simpsons rule, you're finding the approximate definition of the definite integral. Thank you for viewing.